Hello students, how are you? This is Swapna, Mathematics faculty from EDUHUNT IIT and NEET Academy. In the last session, we have discussed about worksheet number 3 and we have discussed up to question number 15 regarding geometric progressions, right? So, in today's session, we are going to discuss about the other problems of worksheet number 3. Let's begin the session. Okay, so what is the first question of our problem? Sum of infinite terms of a series. What is the given question? Sum of infinite terms of series. Sum of infinite means how you will be expressing? Yes, this is series, right? Sum of infinite terms of series means you have to represent with S, and infinite means S infinite. Is, what is the formula? Sum of infinite terms of a series is A divided by 1 minus R. This is the formula, right? A divided by 1 minus R, right? Okay. And before solving this problem, you please tell me what type of progression is this? What type of progression is this? If you have observed the problem, progression, the first term is 3, second term in the mixed fraction, these are mixed fractions, right? So, the whole part of mixed fraction is 5, 7, 9 and so on. If you observe the whole parts, it is like 3, 5, 7 and so on. Correct? Yes or no? And if you observe the fractional part, in the first thing you have 0, in the second term you have 1 by 4, 1 by 4 square, 1 by 4, 1 by 4 square and so on. So, these are the terms which are in GP and these are the terms which are in AP, because you see the common difference in the first one and you see the common ratio in the second progression. So, it is like combination of arithmetic and geometric progressions, right? So, the arithmetic combination geometric, arithmetic combined geometric. So, this is called arithmetic co-geometric progression. Right? Arithmetic co-geometric progression. Co in the sense combined. So, which is in shortcut you will write like AGP progression. So, what is this type of progression? This type of progressions comes under AGP progressions, right? Which is a combination of arithmetic and geometric. Okay. So, given S infinite. So, S series S is equal to what they gave? 3 plus 5 1 by 4 plus 7 1 by 4 whole square and so on. So, let us subtract. First, we will divide with 4 to the above series. So, what you will get? S by 4. What you will get S by 4? 3 into 1 by 4. Right? So, S3 can be written as 3 into 1 by 4. Of course. Right? It is actually 3 by 4, 3 into 1 by 4. Anything is same. Next, 5, 1 by 4 is 5, 1 by 4 whole square. Next, 7, 1 by 4, you have to add one more 4 which is cube. And so on. And so on. So, let us subtract. Let this be the first equation. Let this be the second equation. Subtract S minus S by 4. S minus S by 4. What you are going to get? 3. Next, plus 5 by 4, 5 1 by 4 minus 3 1 by 4. So, what I will write in one more step. Okay. See, plus 5 1 by 4 minus 3 1 by 4. These both are like terms. I am writing like this. Next, 7 1 by 4 square is nothing but 16. 4 square is 16. Minus 5 1 by 16 plus so on. Can I write like this? So, I hope everybody is clear. 3 I wrote as it is. 5 1 by 4 minus 3 1 by 4. 7 1 by 16 minus 5 1 by 16. I have arranged all this such type of terms. Now, in the left side, take LCM as 4. 4S minus S is 3S by 4. So, what is the value? Just see here. 4S minus S is what? It is 3S by 4. It is 3S by 4, which is equals to, just a minute. 3s by 4 which is equal to 3 plus 5 1 by 4 minus 3 1 by 4 is 2 1 by 4. 2 1 by 4 plus again it is like 7 1 by 16 minus 5 1 by 16 is 7 minus 5 is 2. 2 1 by 16 or and so on. So what I am going to do is 3 I will write as it is 3s by 4 which is also equal to 3 plus if I take 2 as common, what I am going to get? 1 by 4 plus 1 by 4 square and so on. 16 can be 1 by 4 square, right? So 3s by 4 is equal to 3 plus. So these are n terms in an infinite terms in an GP. So if you have infinite terms in an GP, sum of infinite terms in a GP formula is S infinity is equal to A divided by 1 minus R. Correct? So what is the value of A here? 1 by 4. Divided is 1 minus what is R? Again 1 by 4 only. Correct? 1 by 4 square divided by 1 by 4 is 1 by 4. So 3s by 4 is equal to 3 plus 2 into 1 by 4 is 2 by 4. Take out LCM, 4 minus 1 is again 3 by 4. Cancel 4 and 4 to each other. So what do you left over with? 3s by 4 is equal to 3 plus 2 by 3. 3 plus 2 by 3. So what do you left over with? Please observe the problem. Next. So we left over with 3 plus 2 by 3. So 3s by 4 is equal to, take out the LCM, 3 is 9, 9 plus 2 is 11 upon 3. So here you need to find 11 upon 3. So here I need to find the value of S over here. So 3 by 4 transform to that side, it will become reciprocal which is 4 by 3. So 11 fourths 44, 3 3 is 9 which is equal to yes. So option C. I repeat again. Okay, so let me take this complete series value is equal to S. Okay, so given arithmetic co-geometric progression, I defined also why it is arithmetic co-geometric progression, because the whole part is in arithmetic series, arithmetic progression, and the fractional part is in geometric progression. So in together it is called arithmetic co-geometric progression. Right. So what I am doing here, this is let the complete progression is equal to S. So divide it 4. So if I subtract first and 2 equations, what I got the value like 3 plus 2 1 by 4, 2 1 by 16 and so on. 3 I wrote as usual. I took 2 common. So 1 by 4 plus 1 by 4 square and so on. Right. 3s by 4 as usual I have written like this. So 3 plus, this is the term in series, a sum of n terms in series in GP. So what is the formula? S infinite is equal to A divided by 1 minus R. Right. So what is the value of A here? 1 by 4 first term, and R here common ratio is 1 by 4 again, right? So it is same, A and R values are same for the above progression, right? A by 1 minus R, simplify it, 3 plus 2 into 1 is 2 by 4 divided by 4 minus 1 is 3 by 4, cancel 4. So you left over with 3 plus 2 by 3 is equal to 3s by 4. So which is, take out the LCM, 3 plus 3 is 9, 9 plus 2 is 11, 11 upon 3. Here you need to find the value of S, transform this 3 by 4 to that side, it will become 4 by 3, right? So S is equal to 11 4 is 44 by 3, 3 is 9. So this is the problem of question number 16. Please observe the problem. If you are done with this, we'll be getting back to next question. Can I get back to next one? Next comes question number 17. So here they were asking you to find the value, the least value of n. So what they were asking us to find out? The least value of n satisfying 1 plus 2 square plus 2 power of n minus 1 must be greater than 300. So what is the given question? You need to find the least value of n, least value of n. Okay. So given series or progression. It is not progression, it is series only because all the terms are being added, right? 1 plus 2 plus 2 square plus so on up to 2 power n minus 1. 2 power n minus 1 is greater than or equal to 300. So this is the given series. Okay, this is the given series. So what you are going to do from this? So first, it is clearly visible like all these terms are in the series in GP. So what is the value of A here? A is 1 and A is 1, right? What is the value of R here? R is nothing but T2 by T1. T2 by T1, 2 by 1 is 2 only. So R is greater than 1. If R is greater than 1, what is the value of Sn formula if it is in GP? A into R power of n minus 1 by R minus 1. This is the formula if R is greater than 1 in a GP. Correct? In a GP. So let's start the problem. Yeah. So given all these things R is sum of n terms in an GP. Sum of n terms in an GP. So what is the sum of n terms in a GP? A into R power of n minus 1 by R minus 1. In the place of this, I have written this. Must be greater than or equal to 300. Correct? So what is the value of A in the question? 1. R 2. Power n minus 1. And this is 2 minus 1 must be greater than 300. Correct? So 1 into same is same, 2 power of n minus 1, 2 minus 1 is 1, I am not writing that, which is equal to 300. 2 power 1, here I need to find the least value possibility of n, so I am transforming 1 to that side, 300 plus 1, it is 301. So 301 in terms of 2 power of something, what is the interval, at what place 301 is being located? So 2 power of 1 is 2, 2 square is 4, 2 cube is 8, 2 power 4 is 16, 2 power 5 32, 2 power 6 is 64, 2 power 7 is 128, 2 power 8 is 256, 2 power 9 is 512. So that means 301 is located in between 256 and 512. So can I write like 301 is less than 2 power of 8 and also greater than 2 power of 9. But what is the possible value of n between this and this? Which value I need to take as a value of n over here? It's very simple. In the question they asked you the least value of 1 but not the greatest value of n. So 301 must be greater than this. So I need to take the value is 8 because it is a least value which have been asked. Right. So 2 power of 8 is equal to 256 which is always less than 301. If in the question for suppose they mentioned you like greatest value, then you have to take like 512 which is 2 power of 9 and n value is 9 over here. Right. I hope everybody got clear with this question. So I solved this problem with the trick called sum of n terms in an GP. If R is greater than 1, we have this formula. With the help of this, I just solved this problem. Which trick we are using for which problem, that is also an important key role. Right? So, am I clear with this problem to all? Can I get back to next question? Please have a glance of the problem. Yes, make it fast. Completed. Can I get back to next one? So, what is my next question? Please read out along with me. Sum of the series to infinity. So, how do you express? So, they were asking S infinite. So, what they were asking? S infinite. So, sum of series to infinite. Right. So, given question is, here I will write, given S infinite is equal to 3 by 4 minus 5 by 4 square plus 3 by 4 cube minus 5 by 4 power 4, so on. Correct? This is sum of n terms in GP. Correct? Obviously, those both are in GP. So if you have sum of n terms in GP, then it is a into r power of n minus 1 by r minus 1 if r is greater than 1. But if you have sum of infinite terms in GP, how will you find out that? A divided by 1 minus r. This is the sum of infinite terms in an GP, right? So given this is a terms are in GP, given series, so how you are going to reorganize it, that is important. So if you observe the odd terms, 1, 3 odd terms, 3 is being common, right? 3 is being common. So S infinity, if I take 3 by 4 is common, not only 3 by 4 is common, right? So first one, in the first place you have, if you take 3 by 4, you will be remaining with 1. Next, 3 by 4 I have took common. So what will be left over with? 1 by 4 square. 1 by 4 square. Next part is 1 by 4 cube. Next part, so on up to this. Am I clear? Next, if you observe the even places, you have minus is common, and at the same time you have 5 by 4 is common. 5, this is actually 4 to the power of 5, okay? 5 by 4 square is common. 5 by 4 square is common. So what you'll have in the first place, if I take 5 by 4 square, you will be left over with 1. Next, I took minus common, so this will be plus only. Next, 5 by 4 square I took, right? So 1 by 4 square will be there. Next, again, I took plus common, so minus common, so this will be plus. 1 by, out of 5 4s, I took 2 4s common, so it will be left over with 4 cube, so on. I hope everybody got clear with this. A very simple reorganizing the terms. So, what I have done, in the first odd number of terms, I took 3 by 4 common. Even number of terms, I took minus 5 by 4 square is common. By observing that, you may able to reorganize it properly, right? So, this is sum of n terms in an GP. It's sum of infinite terms in an GP. So, what is the formula? A by 1 minus R. So, S infinite is equal to 3 by 4 into, what is A? A is first term, 1 by 1 minus, what is R? R is nothing but T2 by T1. 1 by 4 square by 1 is again same, 1 by 4 square only, right? Similarly, minus 5 by 16 into, this is also same like 1 by 1 minus R, 1 by 1 by 16. Let's calculate these both values individually, okay? So 3 by 4 into 1 by 1 minus 1 by 16. So what you are going to get? 3 by 4, 1 by 16 minus 15. LCM 15 by 16, right? Which can be 3 by 4 into 15 by 16 reciprocal the function, which can be written as 16 by 15. Next, if you want to cancel, 3 1s are 3 5s are, 4 1s are 4 4s are. So which is 4 by 5. So in the place of this, I can write like 4 by 5. Now let's solve this part. So what is that? 5 by 16 into 1 by, so this is 16 minus 1 is 15 by 16. Take out the LCM. Just reciprocate the function. 5 by 16 into 16 by 15. 16 cancel, 5 1s are 5 3s are. Left over is 1 by 3. 4 by 5 minus 1 by 3. So, what is the value? S times of infinite is equal to LCM of 5 and 3 is what? 15. So, 3 fourths 12 minus 3. So, minus 5. So, S infinite 12 minus 5 is 7 upon 15. So, what is the answer? It's option C. It's option C. I hope everything is clear with this. Please observe the problem. I'll recall it again. So, what is the problem? Given a combination of two different GPs. Here, what I have done, I just reorganized all odd terms together and all even terms together. So in the even terms, I have minus 5 by 4 square is common, I took it out. And in the odd places, I have 3 by 4 is a common, I also removed it out. And I have applied sum of n terms, sum of infinite terms in an GP. How do you say it is in GP, ma'am? Because we have a common ratio between these two terms. 1 by 4 square and 1 is 1 by 16 is LCM, a ratio. And 1 by 4 cube and 1 by 4 square is again 1 by 16. We have 1 by 16 is a common ratio between the two terms. So I just substituted and I calculated both the terms individually, right? So I simplified it. 4 by 5 in the place of this I got, and 1 by 3 in the place of second term I got. I just again took LCM. I got the answer is 7 by 15. Right? Everybody have enjoyed this problem and understood properly, right? Can I get back to next question with your support? Right? Please have a glance of the problem so that we'll be getting back to next one. Am I clear with this? Chalo, we'll be getting back to the next one. So what is my next question? What is my next question? The value of given, what is the given? A power 1 by 2 into A power 1 by 4 into A power 1 by 8, so on to infinite. So let me take S infinite. So that means they were asking S infinite, sum of n terms in a GP, right? Right. Yes. We will do one thing. S infinite, they were asking what, how do you find out S infinite? A power 1, A to the power of S infinite is equal to, what is the formula? In a GP for infinite terms, A by 1 minus R. This is the formula, right? So how we are going to solve this problem? These are under product, right? These are under product. So A power of M into A power of N. So what you will be doing? A power of M plus N, right? So do all the terms plus. So what is the law? I have used A power of M into A power of N. When bases are equal and multiplied, the powers must be added, right? The powers must be added. So bases are equal, powers must be 1 by 2, 1 by 4, all the powers I just made added, right? So if you observe these powers, the powers are in GP. The powers are in GP. So what consider? What do you have to consider? 1 by 2 plus 1 by 4 plus 1 by 8, so on up to infinity. These are the terms in GP. So what is the value of A here? The first term is 1 by 2. What is the value of R here? 1 by 4 by 1 by 2 is again 1 by 2 only. Correct? Is again 1 by 2 only. So what is the value of S infinite? Tell me. A by 1 minus R, which is 1 by 2 by 1 minus 1 by 2. 1 minus 1 by 2. Correct? So what you got here? Simplify this 1 by 2. 2 minus 1 is again 1 by 2. 1 by 2, 1 by 2 gets cancelled. So sum of infinity is 1. So what I got? Sum of infinity is 1. Just substitute this S infinite in this above equation. We got S infinite is equal to A. In this equation, what do I get? A power 1. So S infinite is nothing but A power of 1 is nothing but A. The answer is option D. I hope everybody enjoyed this class, and we have solved many problems from geometric progression. In the upcoming classes, we are going to see forward many problems regarding progressions, and until and unless, thank you all. Bye bye.